And welcome back, y'all, to Cajun Coding. This is St. Raz, and on to our Array2 series of exercises on Nick Parlente's site, Codingbat. What was the last one we did? We did, same ends. So now we're going on to triple up. The instructions are: return true if the array contains somewhere 3 increasing adjacent numbers like 4, 5, 6, or 23, 24, 25. Now it says return true if we find that anywhere, somewhere. So if we don't find it anywhere, we're going to go ahead and return by default false. And as soon as we find something that satisfies that condition, we'll immediately return true. And let's go ahead and get started. Num's length. Num's length is greater than 2 because we're going to need at least 3, and we'll put our code in there. If the length is 2 or fewer, it'll automatically return false. And you will be writing this in your sleep eventually. Okay, and now we need the comparison to see if we've got what we need to. And actually I already made a little bit of a mistake. Let's go ahead and set that up to 2. So that'll be the third element. We're going to go through the loop until we reach the end of the array. And along the way we'll be comparing our current index to the 2 prior indices. Okay, so if nums I is equal to nums I minus 1, that would be the one prior would be one less, so it would be equal to that plus 1. And nums I is equal to nums I minus 2 plus 2. That would satisfy the condition, return true. And I think that should do it. And it doesn't look like I have any typos this time. I was pretty sure about the logic. I was worried I might have a dangling parentheses somewhere or something like that. If that's a common problem with you working through these exercises, I wouldn't, obviously a little more attention to detail never hurts, you know, and with practice you'll get better at reading it and finding those things. But don't worry about it too much. This is a free website for novices, for students who are working through problems like these, learning the fundamentals. But with more advanced integrated development environments, which you would actually be using in a professional environment, you're going to be using tools that are better at picking up on things like that and highlighting the text so that you can see things like you know, an unclosed bracket or something like that. Now even this uses, if you highlight, when you've got these brackets or curly braces on their own line, if you highlight that, you can see that it highlights these. So when the closed, if you click on the closing one, it'll highlight where it's opened. So definitely use that. So on to the next one here. And I do apologize, I still have a bit of a cold. If you've got like a nice hot lemon and honey hot toddy to make you feel better, the trick to making that work really well is to use it to follow a nice shot of medicine. You know, don't neglect the dextromethorphan and Benadryl and things like that. You know, go ahead and make use of that Western medicine. It works pretty good. So, all right. So phys array 3, given start and end numbers, Return a new array containing the sequence of integers from start up to but not including end. So start equals 5, end equals 10, yields 5, 6, 7, 8, 9, but not 10. The end number will be greater or equal to the starting number. Note that a length 0 array is valid. So let's go ahead and set up our array. So it's integers. We'll just call it answer because we're just so creative like that. And see, don't forget the keyword new. And then the length of the array is going to be end minus start. Now that's going to create an array of the appropriate length. It will be populated all with zeros since it's an integer array and we haven't put something else into it yet. So let me see, answer length. If you were to do end minus start for the length for I is less than end minus start, that would be the same number, so that would be correct too. Alright, and answer I equals, or I should say assignment. Assign answer I equals, assign to answer I. That would be start plus I. And that should do it, and return our new array. I think we can start, yeah, it would have to be a new array because the old array is going to be too long. There we go. Couldn't we shorten, could we return the original array but shorter? Well, the answer is no, not with Java. An array has a defined length, and you cannot change the length of the array once the array is defined. Now there is a structure called an array list, but that's a little bit outside the scope of these exercises right now. An array list has a dynamic length. You can make it longer or shorter as needed, but an array once defined is going to be a set length, which means that has implications in terms of the memory footprint of an application. So let's say you might need up to 100 integers. You'll declare an array of 100 of length 100. If it turns out you don't need all of those, you can put void values like a 0 for an integer or a empty string for a string, whatever you would need. However, so you would be able to work with that. The downside would be that even if you weren't putting a useful value in those addresses, in those memory addresses, those indices in the array, even if a particular index in the array doesn't contain a useful value, there is still a memory address used by the system, and that is going to consume memory even if you're not putting actual data in it. So, but on to the next exercise here. Shift left. Return an array that is left shifted by 1. So 6253 returns 2536. You may modify and return the given array or return a new array. So a couple ways to do that. I'm going to go ahead and set up a temporary variable, and we're going to initialize that to the first element in the nums array. Then we're going to set up our for okay, and as we iterate through the array, nums I is going to be equal to nums I plus 1. And then after we get through that, nums length minus 1 is going to be assigned the value that we held in our temp variable. Then we return the original nums. Now we're going to return the same array. This is the same, the array is the same object that we received, but we've been doing some writing to it, so changing things around. We might have some edge cases like short arrays or something. We might have a bunch of them. What happened here? I think we ran, did we run over the end? Nums length -1. There we go. Hit a bit of the last one because we ran through the end of it. Now we do have this edge case where we're getting an empty array, and we could just put if nums, actually we could just do, instead of using multiple return, if nums length is greater than 0, and then we're going to enclose all of this in those curly braces. So if nums length is not equal to 0, we just skip all of this and return nums, which is the same array we received, which has no elements in it. That way we're not using two return statements there. And the next exercise, 10 run. For each multiple of 10 in the given array, change all the values following it to be that multiple of 10 until encountering another multiple of 10. So 2, 10, 3, 4, 25 yields 2, 10, 10, 10, 20, 20. Okay. Let me see it, and we're going to call this replace because that's going to be the value we're replacing the current value with. We're going to initialize that. Go ahead and initialize it to -1. And we're going to iterate through our array here. So let me see. Now we're going to be writing to our array. I mean, there's values will change, values who won't change, but at the end of everything, we're going to return that array in the way we've changed it. So we'll put that at the very end there. All right, so if nums I modulo 10 equals 0. If that is the case, that means that element of the array is divisible by, evenly divisible by 10. And now we're going to check to see if replace equals -1. If replace does equal -1, then we're going to update replace to the current value of that element. If replace does not equal -1, let me see. Actually, if it's divisible by 10, we're always going to change that. I got ahead of myself here, I think. Okay, so if nums is divisible by 10, then we're going to change replace. If nums is not equal, if it's not divisible by 10, then we check if replace is not equal to -1, then we're going to update nums I to replace. If replace is -1, hold on a second here. If replace, okay, so if it is divisible by 10, then we're always going to update replace. If it's not equal, this else statement, if it's not equal to if it's not divisible by 10, then we need to check replace. If replace is not equal to -1, then we're going to replace it. If it is equal to -1, then we continue. And there we go. Okay, this is the part where it gets kind of tricky. Is before you hit that first one that's divisible by 10, we've got 1, 2, 50. 1 and 2 remain unchanged. Okay, why is that? Because we haven't run into one that's divisible by 10 yet, and that's where this logic takes place. If replace is equal to -1, then we just continue. We just go back to the next iteration of the loop. We don't change anything. If replace is not equal to -1, that means we need to update it. So we're going to change replace to, as we step through here. So we've got 1, it's not divisible by 10. 2 is not divisible by 10. 50 is divisible by 10. So now we're going to assign to replace the value of 50. And then the next one is not divisible by 10. So we're going to write the value of replace, which is 50. And we've got some that switch around a little bit. Here's one that switches around. Now we start at 10, so immediately we're going to write to replace the value 10. So 10, 10, 20, 20, 10, 10, 20, 20. Here we start with 2, we're not changing that, then 10, and then we're going to all divisible by 10 after that. So, and this number can basically be anything that's not divisible by 10, and you need to check it as you go along. -1 is probably a good convention to use for a value that's not valid for a particular function or whatnot. So on to the next one. Let me see. Given a non-empty array of ints, return a new array containing the elements from the original array that come before the first 4 in the original array. The original array will contain at least one 4. Note that it's valid in Java to create an array of length 0. So, first 4. So we'll call that int first 4. And I think 0 would be fine, because basically if it turns out that we don't have one, then everything before the first 4, and if if 4 is actually in the first element in the array, then we would be returning an empty array, so that would be okay. So I would do our for loop to see where that 4 is. If nums I equals 4, first for equals I. Oh, you know what? Actually, let me do this. We're going to do first for equals I, and then we're going to do a break. Because what we don't want, we're going to, if we iterate through the entire array with multiple fours, we're going to update that first for variable, and we're going to lose what it was before. So as soon as we find it, we're going to break out of the for loop. So this is the end of the if. This is the end of the for. Now let's go ahead and set up our array. See, int answer equals new int. Now the index of that first for, we're not going to actually write that, so it's going to be length. Should be first for minus 1. And then we're going to assign the variable, the values into it. Let me see if this works. Well, we're consistent, which means that we're always wrong. Yeah, I think we're just short. That should be minus 1. Might have been wrong about that. Oh, there we go. Why was that wrong? That was wrong because this is less than, not less than or equal to. Yeah. Okay. Oh, one thing I wanted to point out also, I don't think I mentioned this before. You notice that we have this for loop here that uses the I, this I variable for our iterator. And we've got the one right here. That's perfectly fine, because once we get here, this variable basically no longer exists. It's what we call out of scope. The scope for this variable, this I, is important, and it exists in this space. Well, actually, it would be through all of this, the entire for loop. However, once that for loop executes and terminates, that I basically no longer exists. The memory address is free to be used by other functions or methods. And then the designation of I for that variable is also available. So when we get to this for loop and we declare this for loop, we can use I. That's fine. Now, in the case in which you have a for loop inside a for loop, that might work, but it's very strongly discouraged. And actually, in fact, I can think of examples where it's not going to work. So you'd want to use something else. A very common convention is to use J, just the letter right after I. So you would use J for your inner for loop and I for your exterior for loop. If you find that you have a loop inside the one that's using J, you could use K, but you might want to examine your life or at least your coding practices, because for loops nested inside for loops tend to get very memory intensive. They start having a big performance hit. There is usually a better way to do things than putting a for loop inside another for loop. One nested inside another is not that big a deal. Might be a more efficient way to do things, But if you have a for loop inside a for loop inside another for loop, that's almost certainly not the best way to do whatever it is that you're doing. But we're going on to the next one here, post for. Previous exercise I think was called pre-for. This is post for, given a non-empty array of ints. Return a new array containing the elements from the original array that come after the last for in the original array. The original array will contain at least one for. Note that it is valid in Java to create an array of length 0. So let's go ahead and set up last for. And does it say? It does say we have at least one for, so we know we're going to find a for. Okay, and if nums I equals 4, then we're going to set last for to be the value stored in nums I. Now notice, this is almost just like the code I did for the previous exercise. If you don't have the break statement, it'll keep going. And that's what we want it to do in this case, is to keep going through that array all the way to the end, and we'll keep updating last for. And of course, the last time that we find a for will be the last time this is updated. So we'll have that element, the address of the last element to the right. And actually, this is going to always put a for in there. We should just put I. We're not looking for, well, the value in it, of course, is going to be 4. We know that. But that's always going to be the case, because that's what we're checking for. We need the address, so we're going to use I. Okay, and let me see. What are we doing now? We're creating an array. So int answer new int. And this is going to be nums length. That's the length of the total array that we had originally, minus last for, which is the last address that we found for that for. It's going to be minus 1. Let me see. So if we've got 4, so we've got 2. So we've got 4 minus 2. So that's going to give us 2. That's too many. So it's going to be minus 1. Okay. Okay, so this is going to be answer I, and we're going to assign to that nums last for plus 1. That's not it's going to be the same one every time if we do that. Be nums 4 plus 1 plus I. I'm not sure about that one. Let me see. Oh, that is right. Okay. Let me see. Yeah, because what we're doing here is we're going to start at 0 with this loop. So we're starting at the beginning of the array that we created, and then we're going to start writing from the nums array. Last for is going to be the address of the last for, but we're not writing that for, we're writing the one right after it. So we're going to add a plus 1, and then we're going to increment through that to the next address each time. So we're going to add I, which the first run through is going to be 0. So it's going to be right after the for, and then so on. And of course, the way we've got this set up is that we might end up creating an array of size 0, which is perfectly valid. It's just a very tiny box is what it is. We're right at about 30 minutes here. We've got a few left, NotAlone. And let me see. Let me look at NotAlone and see how complicated that is. We'll say that an element in an array is alone if there are values before and after it, and these values are different from it. Return a version of the given array where every instance of the given value, which is alone, is replaced by whichever value to its left or right is larger. And I think we can do this one. Let's go ahead and do this one. It won't run too long, I don't think. Alright, so I don't think we need to create anything to hold those values. So let's go ahead and do our for loop. Int I equals 0, I less than. Actually, I don't think that's correct. We're going to start with 1. I think we might have some edge cases. We're going to worry about the edge cases in just a moment. Let's go ahead and run through this. See if I equals 0. And there's going to be some logic for that. If actually it's never going to be 0. I might have been having a flashback to previous exercise. Let's just do if okay, so if nums I equals the value and nums I minus 1 is not equal to val and nums I plus 1 is not equal to val, then nums I will be assigned the maximum, see math max, nums I minus 1, nums I plus 1. In the end, we're going to return nums. So what's the issue? Oh, here we go. What about these little edge cases? We've got this tiny little empty array here. Okay, why don't we run into error out of bounds? Okay. The reason for that is because I is less than num's length minus 1. This is a for loop. And if this condition doesn't pass, then the for loop won't execute. It won't say we're out of bounds, it just doesn't execute. So the compiler reads this and kicks us right down to here, and then the next line, return nums. So we end up returning the empty array. So if you're our old friend exception out of bounds, okay, you're going to want to know whether you're doing those checks for adjacent addresses outside of a for loop, because if you're doing it, if you're worried about running over the end of an array or a string, but that check only takes place inside the for loop, it's really not something you have to worry about, as in this case there. So yeah, we got through that one pretty good, and we'll start up with 0 front on the next video. Thanks again as always. Appreciate you guys for listening. If you have any questions, comments, requests, critiques, I'd love to hear them. Otherwise, thanks for tuning in, and I'll see you guys next time.